Hello, fellow EGU scientists. My name is Catherine Hutchinson, and today I made a little video for you about the research that we undertook in the Weddell Sea in Antarctica. It's only 3 minutes long, so sit tight and enjoy. Today I'm going to be focusing on specifically the water mass characteristics and distribution in the oceanographic environment adjacent to Larsen Sea. And these findings were recently published in JGR Oceans, so please refer to my paper if you would like any further detail on this research. During the last 30 years, Larsen Sea has experienced considerable variability in its thickness and extent. And an example of this is when iceberg A68 broke off of Larsen Sea in 2017. Questions regarding the environmental conditions in the area motivated for the Weddell Sea expedition, which began at the end of 2018, where myself and my fellow scientists flew from Cape Town to Antarctica via private jet. From Wolf's Fang in Antarctica, we then took a propeller plane to Penguin Bootka, which is the ice shelf adjacent to where the Gallus 2 was parked. We then took a helicopter from the ice shelf onto the Gallus 2. Just in time to spend New Year's at the ice shelf. 2 days later, when the rest of our expedition members joined us, we departed west and headed towards the Weddell Sea, through quite thick ice conditions, but eventually were able to get to the area between A68, that massive iceberg that I spoke about, and Larsen Sea ice shelf. Here we undertook 19 CTDs, focused at the apex of Jason Trough, where the trough abuts the ice shelf. This dataset constitutes the highest spatial resolution measurements in the area to date. The dissolved oxygen measurements that we obtained enabled the use of a linear mixing model to quantify the contributions from the principal source waters in the area. These were modified warm deep water, high salinity shelf water, ice shelf water, and winter water. We found high levels of water mass mixing between modified warm deep water, a water mass with origins in the Antarctic circumpolar current, and local water masses, indicating the potential for transformation of the precursors of Weddell Sea deep water. Now, while the observed presence of modified warm deep water does signal the transport of heat into the area, we cannot identify the potential impact of this introduction of heat onto the ice shelf itself with the available data. To gain improved insight into the ocean-ice shelf interactions in this area, we need many more measurements. Alternatively, we could turn to the use of models, and this brings me to my future work, which is to explicitly include the sub-ice shelf cavity circulation in the NEMO global ocean configurations, and explore key processes that control dense water production and export. Thank you so much for taking the time to listen, and if you have any questions, please do not hesitate to email me on my email link below or reach out to me on Twitter. Have a great rest of the EGU Online. Bye!